I want you to imagine, just for a second, one of the most famous and honestly bizarre questions in modern history.
Oh, yeah. It's a classic.
Right. It's this idea of, can a cat be both alive and dead at the exact same time?
Which, I mean, on its face, it completely defies common sense.
It totally does.
Yeah.
But today, we are using that exact question, the famous Schrödinger's cat paradox, to, well, basically break down the nature of reality itself.
Yeah, it's going to be pretty wild, right?
For sure. So for our mission on this deep dive, we are going through a stack of sources that will take us from, a sealed box, a radioactive atom, and a vial of poison straight into this really radical philosophical framework.
A framework that honestly challenges, everything you think you know about the universe around you.
Exactly. So welcome to the deep dive. Let's just jump right in.
It really is a profound journey. I mean, we are going to deconstruct what it actually means for something to be, quote unquote, real. And to do that properly, we really have to start with the physical setup, right? We need to look at the actual thought experiment that was proposed by the Austrian physicist Erwin Schrödinger back in the 1930s.
Okay, so let's set the scene for you listening right now. I want you to imagine a steel box.
A very specific kind of box, yeah.
Yes, exactly. It is completely opaque and totally sealed off from the outside world. You cannot see, hear, or measure absolutely anything happening inside once that lid is shut.
That isolation is key.
Right. Now, inside this box, we place a living cat.
And alongside the cat, we place this highly specific, basically probability-driven contraption.
Okay, yeah, let's unpack this contraption.
So the sources detail 4 key components. First, there is a single radioactive atom.
Just one.
Just one. Second, there's a Geiger counter, which is, a device designed to detect radiation.
Right.
Third, there is a small mechanical hammer connected to that counter. And fourth, there is a fragile glass vial filled with a really deadly poison gas.
Okay, so let's walk through the mechanism here, because the causality of this whole thing is crucial.
It really is.
So radioactive atoms are by nature inherently unstable, right? And they decay randomly.
Exactly.
We can't predict exactly when a single atom will decay. I mean, we only know the mathematical odds over a given period of time.
Yeah, exactly. Let's say there is exactly a 50% chance that this specific atom will decay in the next hour, and, a 50% chance it won't.
So it's basically a subatomic coin flip.
That's a great way to put it. Now, if the atom decays, it releases a tiny particle of radiation.
Okay.
The Geiger counter detects that particle. The counter clicks, which then triggers a relay, which releases the hammer.
And the hammer falls, smashes the glass vial, the poison gas fills the box, and, well, the cat dies.
Unfortunate for the cat, but yes.
Right. But if the atom does not decay during that hour, no radiation is released.
Right, so the Geiger counter stays completely silent.
The hammer stays locked, the vial remains intact, and the cat lives.
So that is the physical setup. And what Schrödinger did here was just ingenious. I mean, he tied the macro world, the everyday world of cats and glass vials directly to the micro world.
The deeply unpredictable, probabilistic world of a single subatomic particle.
Precisely.
But, I mean, how does a random atom dictate the fate of a macroscopic cat in a way that, breaks our understanding of physics?
Whoa.
Because in our normal experience, we would just say, well, the atom has either decayed or it hasn't. We just don't know yet because the box is closed.
Right, yeah.
It seems like a simple issue of our own ignorance, the universe knows what happened. We just haven't looked yet.
And that is the intuitive assumption. But our sources highlight that according to the rules of quantum mechanics, that assumption is fundamentally wrong.
Wait, wrong? How?
Well, until we open the box to check, the math tells us the atom isn't in one state or the other. It is physically in a state of having both decayed and not decayed.
Okay, let's unpack this. I really want to pause and dig into the mechanism here, because this is usually where people just, get completely lost.
Oh, absolutely. It's totally counterintuitive.
Yeah, it sounds like a mathematical trick, or just scientists saying, we don't know. Why do physicists actually believe the atom is physically in both states at once?
That is the critical question. And we know this isn't just a lack of information because of how quantum particles behave in actual physical experiments.
Like which one?
Well, like the famous double slit experiment. Have you heard of that?
Oh, right, yeah, where they shoot particles at a wall.
Exactly. If you fire single quantum particles at a barrier with 2 tiny slits in it, and you don't measure which slit they go through, they don't just build up in 2 clusters on the wall behind it.
Right, which is what you'd expect if they were like tiny bullets.
Exactly. But instead, they create an interference pattern. they create this complex series of bands, exactly like ripples of water overlapping and crashing into each other.
So wait, the particle actually goes through both slits at the same time?
Yes.
And mathematically interacts with its own alternate possibilities.
Precisely. Because if the particle simply went through one slit or the other, and we just didn't know which, there would be no interference pattern at all.
Oh, wow. Okay.
The math forces us to accept that both states are physically interacting until we actually look at them. This is called quantum superposition.
Superposition.
Yeah, the particle literally exists in a combination of all its possible states simultaneously. It's described as a wave of probabilities.
Okay, so bringing it back to the box. Because the fate of the cat is perfectly tethered to the state of that single atom.
Yeah.
If the atom is in a superposition of decayed and not decayed, the cat must be in a superposition too.
That's the logic, yeah.
Therefore, until you open the lid, the cat is literally simultaneously alive and dead.
Which completely violates the basic law of non-contradiction. I mean, it breaks our brains.
It really does. So is this... I'm trying to think of an analogy. Is this like a suspense movie where the director films two different endings, and until the movie is released, both endings are technically real in the studio vault?
Not quite. It's actually weirder than that.
Really?
Yeah. It's more like both movies are playing on the exact same screen at the exact same time.
Oh, man.
Right, overlapping and interfering with one another until the audience walks into the theater and then the projector violently snaps to just one ending.
Okay, that is a much more accurate and terrifying way to picture it.
Yeah, but it is vital to understand the historical context here of why Schrödinger even came up with this.
Right, because he wasn't actually trying to prove that cats can be half ghosts, right?
Exactly. A lot of people think he was trying to prove that quantum physics is magical. He wasn't. He was actually criticizing the prevailing interpretation of quantum mechanics at the time.
Oh, interesting. So he was using it as like a massive red flag.
Yes, perfectly said. He was essentially telling his colleagues, hey, if your math is right about the micro world of the atom, and we scale it up to our world, it means this cat is a zombie.
And since zombie cats obviously don't exist, your theory must be missing something somewhere.
Exactly. He designed it to show just how absurd things get when you try to apply superposition to the everyday macro world.
But that raises a really obvious question for you, listening to this right now.
For sure.
Because if particles like electrons and protons can be in multiple states at once, and modern science proves they absolutely can, why don't I see half-alive, half-dead things on my morning commute?
Right. Why isn't the traffic light both red and green?
Exactly. Why is my reality so solid?
Well, the scientific answer to that problem of scale is a concept from our sources called decoherence.
Decoherence. Okay, let's break down how decoherence actually works.
So while tiny things like single electrons can easily maintain a superposition, that quantum state is incredibly fragile.
Like how fragile?
Extremely. The mathematics of superposition require absolutely perfect isolation. The moment that quantum state interacts with the messy, complex environment around it,
Even just a little bit.
even just bumping into a single air molecule,
Yeah.
or absorbing a stray photon of light, the superposition immediately leaks away into the environment.
It gets scrambled.
Exactly, it gets scrambled.
So a macroscopic object, like a cat, which is made of trillions upon trillions of atoms continuously bumping into each other and radiating heat, can never maintain perfect isolation.
Not a chance. The thermal noise of the living body, the air inside the box, the metal of the hammer, all of these trillions of interactions act as constant, unrelenting measurements.
Wow. So the quantum effect naturally hides itself almost instantly.
Yes, this is decoherence. The environment itself is constantly measuring the object, forcing it out of superposition long before we ever even get to look at it.
Okay, so the weirdness washes out before it ever reaches the scale of a cat.
Precisely.
But let's go back to the fundamental core of the physics problem here. Let's say, theoretically, we have perfect isolation.
Okay, an undecohered quantum system.
Right. What actually happens the very split second we make a measurement? Because I've never observed a blurry dual-state particle, I only ever see one clear outcome.
Right. So when you measure the system, you cause what physicists call the collapse of the wave function.
The collapse.
Yeah. The instant an observation occurs, those simultaneous overlapping states can no longer coexist. The superposition breaks, the mathematical wave of probability collapses into a single concrete point of reality, and you get a clear binary answer.
But this is where physics hits a massive brick wall, doesn't it?
Oh, the biggest wall imaginable.
We have this terrifying concept called the measurement problem.
Yep.
Because if the math says the universe is this swirling wave of overlapping probabilities, and it only settles into a definite reality when it is measured, well, what constitutes a measurement?
You've hit on the exact crisis that has plagued physics for a century. This is known as the von Neumann chain.
The von Neumann chain. Explain that a bit.
It asks, where does the collapse actually happen? Does it happen when the radioactive particle hits the Geiger counter?
Because if the Geiger counter is made of atoms, why doesn't it just enter a superposition of clicking and not clicking?
Right. And then the hammer enters the superposition of falling and not falling.
And the cat enters the superposition of hearing the click and not hearing the click.
Exactly. You can mathematically trace this chain of superpositions all the way out of the box.
So does the collapse happen when the light from the box hits my retina? Or does it happen when the electrical signal travels down my optic nerve?
Or, and this is the really wild part, does it happen in the immaterial consciousness of the human observer?
Wait, does the universe need a conscious mind to force it to make a decision?
That's the implication some draw from it.
It makes us sound like the ultimate directors of reality. Like, if we don't look, the universe doesn't pick an ending.
And you can imagine it is deeply unsettling for scientists who operate on the premise of a solid, objective universe.
I bet.
For decades, physicists and philosophers have argued endlessly over how to solve this. I mean, some proposed parallel universes branching off to accommodate every outcome.
The multiverse theory.
Exactly. Some propose hidden variables we just can't measure yet. They're desperately trying to fix the physics to save the concept of an objective reality.
So physics basically gets stuck.
Completely stuck.
We have this profound measurement problem where human observation seems to dictate reality, and scientists are basically ripping their hair out trying to fix the math.
Yes. But our sources suggest the math isn't broken.
Oh.
Our basic assumption about reality is.
Here's where it gets really interesting. This is where the sources introduce a completely different lens for us to look through.
We are stepping out of the physics laboratory now.
And into the AP framework.
Exactly. The AP framework, which stands for Advaita philosophy.
Okay, for the listener, what is Advaita philosophy?
So Advaita is a classical tradition of non-dualistic philosophy. And it looks at this decades-long debate, looks at Schrödinger's thought experiment and says, science is completely missing the point.
Wow. How so? What is the AP framework's radical pivot here?
Well, Advaita philosophy executes this pivot by stating that the entire scientific confusion around wave function collapse is rooted in a fundamentally flawed assumption.
An assumption that scientists don't even realize they're making.
Exactly. Scientists are confused because they assume, as like an unquestionable foundational premise, that a stable, independent physical reality exists before they look at it.
Oh, I see.
They assume the box, the atom, the poison, and the cat all have an objective existence that has absolutely nothing to do with the human observing them.
So they assume the universe is essentially a physical stage, and we are just, actors walking onto it. The stage, the props, the lighting, they are all there whether we are in the theater or not.
Precisely. That is exactly it. And the framework argues that this assumption is the core error of modern science.
Okay, so to understand why that's an error, we have to introduce this really fascinating concept from the sources.
Ah, yes, the concept of ahankar.
Ahankar. Let's spell that out. In this philosophical tradition, ahankar is often loosely translated as the ego, right?
Yeah, but we need to be really careful here. It isn't ego in the modern psychological sense of like vanity or arrogance.
Right. It's not about being full of yourself.
No, not at all.
Yeah.
Etymologically, aham means I, and kar means maker, so it translates more accurately to the eye maker.
The eye maker. Okay, how does that mechanism work?
Ahankar is the underlying cognitive faculty that basically draws a boundary in the continuum of existence and says, okay, this side of the line is me, and that side of the line is the universe.
It creates the subject-object split.
Yes. So the core argument of the AP framework is that reality is not independent at all. The physical world we experience is inherently, inextricably organized by this I make.
Okay, wait. I have to push back here on behalf of the listener.
Go for it.
Because if I leave a glass of water on the table, walk out of the room, and come back a minute later, the glass is still there.
Sure.
Are these sources literally arguing for solipsism? Like, are they saying that the physical universe just vanishes into nothingness when I blink? Because that honestly sounds absurd.
That is a vital distinction to make, and it's a super common misunderstanding.
Okay, good. Clarify it for me.
So solipsism argues that your personal individual mind is the only thing that actually exists, and everything else is just a hallucination.
Right.
Advent philosophy isn't saying the raw underlying substance of the universe vanishes when you look away. It's saying that the object, the glass of water or the cat, as a distinct, separated, categorized entity, is a construct of your ahankar.
Oh, I think I get it. So the conceptual boundary that makes a cup or a cat only exists because of my cognitive architecture.
Yes. Think about what a cat actually is. To even conceptualize the cat, you are using the specific tools of your consciousness.
Like my perception of space, my experience of time.
Exactly. Your memory, your sensory input. How the cat is in itself, what philosophers call the thing in itself, is fundamentally unavailable to any living ego.
Because I can't be anything other than me.
Right. You cannot experience a cat without the eye maker organizing the sensory data into the shape of a cat.
Because the only way I can interact with the cat is through the lens of my own cognition.
Right.
And if I try to step outside of that cognitive structure to see what the real universe looks like without me looking at it, I run into an impossible paradox.
Exactly. If you step outside of the eye maker, there is no eye left to return and report what it observed.
Wow.
You cannot use the ego to perceive a reality absent of the ego. It's literally impossible.
So, bringing this all back, this entire time, physicists have been staring at this steel box, trying to figure out what the physical cat is doing when no one is looking.
Yep.
And the AP framework is pointing out that the very question is broken.
Completely broken.
There is no isolated cat when no one is looking. The concept of a cat is an experience happening to a knower.
Which turns Schrödinger's thought experiment from a physics puzzle into a profound psychological mirror.
A mirror. I love that.
Yeah, it acts as a trap for scientists. They're trapped because they desperately desire an objective reality that exists independently of the observer.
They want a universe they can measure, categorize, and control from a safe, detached distance.
And the framework asserts that this very desire, this need for the universe to be a separate mechanical clockwork, is an illusion generated by the ahankar.
So if we connect this to the bigger picture of how we live our lives, the sources are essentially asking us to reevaluate every single thing we consider a solid fact of reality.
Absolutely. Reality always demands a specific clarifying question.
Which is?
Reality for whom?
Reality for whom? Man, you really cannot separate the known from the knower.
Never. And the honest, unavoidable answer to reality for whom is always for the conscious entity that is currently experiencing it.
Which brings us to the final, ultimate revelation about the cat state inside that box. When we finally open the lid, the framework argues that the cat is neither alive nor dead, independent of the ego's knowledge.
Exactly.
And why is that? Because alive and dead are not objective, universal facts stamped onto the cosmos. They are human categories.
The universe doesn't know what dead is. The universe doesn't know what alive is. Those are biological labels we invented.
Right. We categorize a certain complex configuration of atoms undergoing respiration and cellular mitosis as alive.
And when that specific movement stops, we categorize it as dead. But that is just our conceptual filing system. It is not a fundamental property of the universe.
It's like wearing permanently tinted green glasses your entire life and then agonizing with your colleagues over the true color of the room you're sitting in.
That's a brilliant analogy.
You ask, is the room objectively green before I walk into it? But the true color doesn't exist without the glasses because your vision itself, the tinted lenses, is what creates the color green in the first place.
Right.
You can't take the glasses off to check because the glasses are your very consciousness. The room isn't green. Your experience of the room is green.
That analogy perfectly captures the mechanism of the ahankar. The ego is the tinted glasses.
Oh.
The physicists are arguing about the objective state of the room, failing to realize the lenses are permanently affixed to their own eyes. Huh. The Schrödinger's cat paradox only exists because we insist on projecting our ego-created categories, alive, dead, atom, box, onto a universe that doesn't actually operate with those conceptual boundaries.
So what does this all mean for us? We started this deep dive looking at a simple steel box and a radioactive atom.
We really went down the rabbit hole.
We did. We explored the genuine scientific mechanics of quantum superposition, where particles interact with their own possibilities until forced into a single state.
Right, and we looked at how the thermal noise of decoherence hides this weirdness from our daily lives.
And how the measurement problem forces scientists to confront the role of the observer.
And then we took that necessary leap with the AP framework.
Moving from quantum mechanics to the mechanics of consciousness.
Realizing that the entire setup, the box, the cat, the poison, and the outcome, are not independent physical truths, but constructs organized by our own eye maker.
The trap isn't the complex mathematics of the wave function. The trap is our deeply held assumption that reality exists as a categorized physical structure without us there to experience it.
It is a complete paradigm shift. It takes the mystery out of the sealed box and places it squarely behind your own eyes.
It really does. Which leaves us with one final, deeply provocative thought for you to chew on long after you finish listening to this deep dive today.
Think about this. If all of this, the categories of alive, dead, atoms, boxes, planets, stars, if all of this conceptual structure relies entirely on the observer to exist as a comprehensible reality, what happens when you remove the observer?
Right.
If you completely remove the ego, there is no knower. And if you remove the knower, the known reality itself ceases to exist. There's no independent, categorized universe left behind the curtain.
That is just wild. Think about that the next time you look at a simple glass of water on your table and assume it's just objectively there. Thank you so much for joining us on this deep dive. Keep questioning the reality you see, because it might just be the reality you are creating.